A new report documents evidence that raging floodwaters repeatedly tore across the delta deposit in ancient Lake Jezero. So, what did Perseverance see that shows this?
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars.
Perseverance was sent to Jezero Crater, also pronounced Yezero, to explore the ancient delta deposit for signs of extinct microbial life. Billions of years ago, water flowed through an inlet channel into the crater, dropping sediment into a delta deposit and forming a lake. An outlet channel on the opposite side shows that water must have filled the crater before flowing out. The first science paper from the mission, which was published last week, shows that the tranquil flow of water into Lake Jezero occasionally was disrupted by raging floods. Perseverance landed about 2 kilometers, or about 1.2 miles, from the delta. The zoom lens on Mastcam Z was used to produce this stunning panorama of the cliffs at the eastern edge of the delta. We'll stop here to check out the covers that were dropped by Perseverance back in March. Here's Mars Guy for scale. The black one was used to protect the Ingenuity helicopter during landing when it was folded up underneath the rover, and the thin flat one protected the internal hardware used for sample tube preparation and storage. Next stop is one of the prominent cliffs that the SuperCam instrument aimed its telescope at. It takes circular pictures that can be cropped and mosaicked together to make a panorama. This one has 5 frames. With this incredible close-up view from more than a mile away, layered deposits are visible along with abundant boulders and cobbles. An outcrop with tilted layers looks like foreset beds, the deposits produced at the front edge of a delta as it builds out into a lake. But it's the rounded boulders eroding out of the delta that are evidence of powerful floods. Here's a flash flood flowing toward Lake Powell in northern Arizona. It's the kind of flowing water that can drag large boulders along a channel floor, rounding off their sharp edges and corners. When the flood passes, the rounded rocks pile up in a deposit known as a boulder conglomerate, a telltale sign of high-energy floods. The boulder conglomerates in the Jezero Delta are interspersed with thinly bedded rocks that come from slow-moving water. All of this points to variations in the flow of water into Lake Jezero. But what caused these variations? The flash floods could have been caused by intense rainfall events in the watershed, like the example in Arizona. Rapid snowmelt episodes are also a possibility, or maybe even rapid release of water from glacial lakes in the watershed. From the available observations, it's not possible to identify the specific cause, but it is clear that this was once a place with dramatic episodes of flash flooding.